All right. Our next physical property, density. Okay? By definition, density is the amount of matter packed into a certain volume. Okay? We find it by taking the mass of the substance divided by its volume, but we'll get to that later. Okay? In talking about density, you got to be very careful. Mass is how much stuff is in the object. Volume is the size of the object. Okay? The density is a combination of the two. So, looking at these two cubes here, which of these is bigger in size? The left one or the right one? Brian?
The left.
It's bigger than this one.
Yes, because the particles are moving around, so it's spread out.
Okay. What if let's take our classroom, for example. What if I took all the 5th grade students and packed them into our classroom? Is that going to make our classroom any bigger?
No.
No. We're just going to be more tightly packed in here. Right? So does that mean that this one is bigger? Because there's more space? No. It does have more space, for sure. Which one is bigger in size? Wyatt?
The one on the right?
The right one is bigger in size than this one?
No. They're both the same.
They're both the same size. It's kind of like this. These two cubes. Which one is bigger in size? Brooklyn? None? Is that what you said? Yes, neither of them. They're the exact same size. However, if you hold them in your hand, you can tell that one has much more mass than the other. Okay, let me show you. All the people, hold on. Put your hands up.
What, all of us get to do it?
Which one has more mass? That one? That one?
Oh, whoa, this one.
That one?
Oh,
Has more mass? What?
yeah.
No.
And also because the other one's metal. That's why.
Well, this one's copper. This one's pine, like pine wood.
Yeah, I know.
Okay?
So it's
You guys can pass them around. But I want you to see that even though those blocks are the same size, one certainly has more mass than the other. That's what we have here. Okay? All right, we got to do two things at once. We're going to pass around, but you also got to listen. Okay? Density has to do with how much stuff is packed into the matter. Okay? These are the exact same size. But this one certainly has more stuff in it, right? It's certainly more tightly packed together. Now, relative density is similar, but a little bit different. Relative density has to do with the object's density in relationship to water. Okay? Relative density is floating or sinking when compared to water. Greater density than water will sink, and less density than water will float. Okay? Look at this little bag right here. Is the yellow bag, is it less dense or more dense than the water? It's floating, so is it less dense or more dense than the water? Edgar? Less dense. Good. What about the green bag? Is it less dense or more dense than the water? Chloe?
More dense.
More dense. What about the one in the middle? Connor?
It's just a little bit more dense, so it doesn't completely sink. It kind of stays in between.
It actually has the exact same density as the water. It will not float, nor will it sink. It's exactly the same. It hovers in the middle. Okay? Did everyone get to see the blocks?
Yes.
Good. Easy peasy. Aiden?
So, at my house we have a swimming pool, and there's usually a bunch of leaves in it.
Mm-hmm.
And so every now and then there are a couple of leaves that just float in the middle.
Mm-hmm. Yeah. Probably because they're the exact same density as the water. Interesting. So, this also explains why a ship or a boat will float on the water, but if I step on the water, what happens? I sink to the bottom, right? The reason is, yes, the boat has more mass than I do. It also has more volume than I do. It's certainly much bigger than I am, okay? But the boat will float because its density, the mass is spread out to where it has less stuff packed in the space. I am smaller, but I have a lot more stuff packed into me. So I'm a lot more dense. When I step in the water, I float. But the way the boat has spread the mass out, it floats. Did I say float? I'm sorry. When I step in the water, I sink. Okay? Now, people will say, Miss Wrestling, what happens when you lay, you can lay on your back and hold your breath, right? You can float in the water. Yes, you can, but that's because you have oxygen in your body. Okay? If you just step into the water, you will sink. All right? But the oxygen in your lungs will cause you to float, at least a little bit. Now, there is a particular ocean that you can get in and actually float. Do you know what it is?
I think it's the Black Sea.
Not the Black Sea, the Dead Sea.
Yeah,
Okay? Called the Dead Sea because the water has so much salt in it. Okay? So, in that example, I would float because, yes, I'm dense, but that water is full of stuff. It has so much salt in it that the water is actually more dense than I am.
Wait,
So that I will float. You can't walk on it, no. But you can sit on it and float a lot more easily.
Wait, can you crawl?
No. But that's because of different properties. But no. Yeah. Brian?
What the Dead Sea was called a Dead Sea? For that when you lay down, look dead.
No, it's because living things can't survive in it. Plants die, fish die, all kinds of organisms die. Because there's not enough oxygen. It's just salt water. Yes.
Was there a type of fish kind of animal that can run on water?
Yes. And that has to do
That's tiny bugs.
Whoa. That has to do with a couple different properties, but yes, that lizard is certainly less dense than we are. Connor, last one.
So first, how you can remember that is the Dead Sea has more density.
Mm-hmm.
And also,
Okay. All right. No, last one. We're gonna move on. Next part. Density. Density can be found by taking the object's mass, Chloe, and dividing it by its volume. Okay. I want you to write the definition, and then in the box below that, write the formula. D equals M over V. D equals M over V. Now, that's the exact same thing as D equals M divided by V. So, I want you to write this in the box, but I want you to write this next to it. D equals M divided by V. In the equation, the D stands for density. Density equals mass divided by volume. Okay? All right, I'm going to play the video for you, and then we're going to practice this a little bit.
All objects around us have two things in common. They have mass and volume. Everything that has mass and volume is matter. The mass of an object is a measurement of the amount of matter it contains. The greater the matter of an object, the greater its mass. Mass is measured in kilograms or its derived units.
Okay, we learned that mass is measured in grams. Okay, the unit grams can be converted to kilograms. A kilogram is just 1,000 grams. Okay, so you can have a gram is just 1, kilogram is 1,000 grams, milligram is 1,000th of a gram. Okay, you can have centigram, all those kinds of things. Okay, so it's the same unit, just derived in a different way. Yes. Okay, I'll see.
The volume of an object is a measurement of the space it occupies.
Okay, now, let me explain this to you real quick. When finding the volume of an object, you learn in math class that there are formulas for finding volume for certain things, right? For a cube, the formula is length times width times height, right? Volume of a prism, okay? Length times width times height. Volume of a pyramid has a certain formula. Volume of a sphere has a certain formula. Those are for regular size objects. But what do you do when you have an irregular sized object, like this? There is no way I could take a ruler and measure the height and the one here and here. Well, plus there's space on the inside of here. It's not a solid object. So that would be an incredible pain to try and find the volume of this, right? So instead, what you would do is you would take a graduated cylinder, looks like this, or like this, or like this one, okay? And you fill it up with water to a certain measurement. Maybe I want to fill it up to 60 or something, okay? Then I would drop whatever object I'm trying to measure into the cylinder or the beaker. This wouldn't fit, obviously, but it would fit a beaker, okay? And then you measure what the reading is after you put the object in, okay? That is the displaced volume. Before I put the object in, I was here. Once I dropped it in, now I'm up here, which means that change is the volume of my object. Does that make sense? Okay, so watch this and I'm going to explain it again.
The greater the matter of an object, the greater its volume.
Okay, this little triangle here is the Greek symbol delta. In science, it means change. So this is showing you the change in volume was 30. Okay? Before the rock went in, the volume of the water was here. After the rock went in, the volume was up here. It changed 30 units. Okay? Over here, we have a smaller rock. This change in volume was only 10. The water only went from here to here. Okay? Which makes sense. The bigger rock will cause a greater change than the smaller rock. Correct? So the volume of this rock is 30. The volume of this rock is 10. Which makes sense. Think about it. If you're going swimming, who will cause the hot tub to overflow more? A fat guy or a small guy? Fat guy, right? He will displace more volume out of the tub. Make sense? Okay.
Volume is measured in cubic meters or its derived units. On the other hand, density is the ratio between mass and volume.
Okay, so now we're going to put the two together. We know how to find mass by using a balance and mass pieces, correct? We now know how to find the volume, either by formula or by displaced water or displaced volume of a liquid. Correct? Okay.
It is a property of materials, since each material has its own specific density.
Okay. To find the density, you take the mass and divide it by the volume. Okay? Or take the mass and divide it by the volume.
Therefore, different objects made of the same material always have the same density.
Okay. This is also important to notice as well. Okay? Even though the objects are different sizes, if they are made of the same material, they're still going to have the same density. Okay? Look at this. These beakers are all filled with water, but different amounts, right? This beaker has 10 grams. This beaker has 50 grams. This beaker has 100 grams. Okay? What's 10 divided by 10? Class?
1.
What's 50 divided by 50?
1.
100 by 100?
1.
Okay. The density of all of these is 1. Look at the wood. The little cube of wood only has a mass of 29.4 grams. The chess piece has a mass of 58.8 grams, but this guy is much, much bigger. He has a mass of 196 grams. Size-wise, obviously he is much smaller. He is a little bigger. He's a lot bigger. Okay? But each of these divided out will all equal the same density because they're all made of the same kind of wood. Does that make sense? Okay. So all of those will have a volume of
Different objects made of
0.98.
the same material always always have the same density, regardless of their mass and volume.
Okay? So, that's kind of where he stops. Now, we're going to write the steps for finding density, and then we're going to practice it. So, this is the next part of your notes. To find the density, step 1, you find the mass of the object. How do you find mass? Well, by now you should know you use a balance. Either a balance with mass pieces or a triple beam balance, like what we practice in class. Step 2, you're going to find the volume of the object. There's 2 ways to do that. If it is a basic shape, you're going to use the formula for volume of basic shapes. If it's a cube, you'll use the formula. Length times width times height. If it's a rectangular prism, same thing. Length times width times height. If it's a cylinder, pi times the radius squared times height. If it's a cone, 1/3 times pi times the radius squared times height. If it's a sphere, 4/3 times pi times the radius squared. These are all formulas that we have in math. We just know those work. Okay? In that case, we don't have to measure it with displaced volume. We just know how to find it. Okay? If the object is irregular, okay, look at this object here. This is not a perfect square. It's not a triangle. It's not a circle. It has a weird little cutout thing here, a diagonal line here, another diagonal here. It's an odd shape. You can't measure that. So, for an irregular shape, you measure the displacement or the change of water when placed into a graduated cylinder. What is the reading of the red water before putting the object in? What's the reading over here? Jacob? 7 milliliters. Good. What is the reading after you place the object in? Connor?
9 milliliters.
Good. So what is the change in volume from 7 to 9? Micah? To what? Huh? Not grams, that's mass. We're measuring volume. This was 7 milliliters, now we're at 9 milliliters. What's the change? 2 milliliters, very good. So the volume of this object then is what, class?
2 milliliters.
2 milliliters. Volume is always in milliliters. Okay? What's the displaced volume here? Someone give me an accurate reading over here. Edgar? Good. Here's 30. Let's double check. 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Yep. This one right here, 32 milliliters. What about over here, after we put the fish in? What's the reading? Caleb? 40 is right here. Is that where the water is? $39 is here. But you want to read it at the bottom of the curve. $38 what? Very good. 38 milliliters. Okay? So, based on that, what is the volume of the fish? Wyatt? 6 milliliters. Very good. Okay, everyone's got to do that? Good. Now, putting it all together, we're going to practice calculating density using the formula. I want you to copy this word problem first, and then I'm going to show you how we're going to solve it. There's a specific way to do it. The word problem says this. If you have a mineral sample, so a rock of some sort, with a volume of 4 milliliters and a mass of 20 grams, what is the object's density? Copy that first, and then I'm going to show you the steps. Brian, just making sense?
Yeah.
You're following along?
Yeah.
Good. Okay. First thing you have to do is write down the formula you're going to use. Well, we're trying to find density. So we're going to write the density formula. Density equals mass divided by volume. Write that first. Jacob? Hold on. We'll get there. Write the formula first. Density equals mass divided by volume. Now, I know that it's asking me to find density, so I can't replace the density with anything. But it tells me the volume is 4. Okay, so instead of writing a V this time, I'm going to write 4 milliliters. What else does the question tell me? Luke? The mass is 20 grams. So, what do I have to do? Take 20 and divide it by 4. Jacob, what's the density of our sample?
5.
So, density, you have to write D equals 5, but now I have a problem. I can't leave the 5 by itself. That could mean anything. I need to have a unit. But how do I write a unit for grams divided by milliliters? That's 2 different units. Instead, we just combine them. Grams per milliliter cubed. You see how we just smashed them together? Grams / milliliter. And then you add the cube because it's the volume. Okay? Everyone see how to do that? Okay, so those are the 3 steps. You rewrite the equation, replace your letters with the numbers they gave you, and then solve. And make sure you have a unit. Okay? Luke?
Just kind of a
Sort of, kind of, not really. Some of it will be like this, yes. Okay? Alright. Now, I'm going to pass out your homework. You can write your name on it, but don't start because there are things we have to go through first. Okay? Connor, you can go very quickly. It will be confusing if you don't listen to me. Okay? Write your name and date and then wait. Alright. Write your name and date and wait.
So are we going to measure the density of atoms?
Of actual things?
Of volume of atoms?
I'm not sure actually.
Because I have some gemstones at my house that I don't know. Oh, me too.
Oh.
Not like,
Well, you could measure the volume yourself.
I know. But I don't.
Okay. First thing. This is a little unusual for us, so make sure you write it. This does not need to be in complete sentences. At the very top of the page, write not complete sentences. Now, keep in mind that just because it doesn't have to be in complete sentences does not mean you can give me a one-word answer. Okay? If you briefly check over all these questions, everyone has a question and then it says explain. Explain means explain to me why you chose that answer. That's going to take more than one letter, more than one word. Okay? All right. Read this little paragraph with the instructions up here. Nice and loud, Brian.
Mass volume and density without numbers. Oh, we have recently talked about the relationship between mass volume and density. In this worksheet, we will continue to explore this relationship.
Relationship.
Below are several squares of various sizes which represent their volume. The number of dots inside the squares represents the mass of the object. Answer the questions about the squares that follow.
Okay. All of the questions will be in reference to these 6 items. A, B, C, D, E, F. Okay? All of them are boxes or square or blocks, basically. Okay? And the dots inside of them represent the atoms that make up the squares. Okay? So let's look at the first question. Which object has the greatest mass? And explain. Someone raise your hand and tell me which object do you think has the greatest mass? What?
C?
Why do you think C?
Does it have the most atoms?
It has the most atoms? How do you know?
Like, I don't know.
Sophie, what do you think?
I think C because it has the most atoms and I know it's not really tight together.
Okay, tightly packed together is density. So C is the most dense, but does it have the most mass?
Oh, huh?
Why F?
So larger?
That's volume. The largest is volume. Mass is strictly how many atoms are in the substance. Layla, what do you have to do?
It's E because there's the most atoms.
How do you know?
Because even though it's smaller than F, they're not like so far apart.
Okay, but there is a way you can know for sure. You can prove E does have the most mass, but there's a way you can prove it. Brian, what's your name? Aiden?
So E has the most mass because if you look at the items on the top and the side, the top is 8, the side is 7. So you would multiply 8 by 7 to get an answer. And I counted all of C's atoms and it's 59.
Okay. Well, you can't do that because look, there's 1, 2, 3, 4, 5, 6, 7, 8 dots in the first row, and 1, 2, 3, 4, 5, 6, 7 dots in the second row. There is a way you can prove that E is the correct answer. Jacob?
Because
Connor?
So I calculated them by counting it up, and C actually, E almost had twice as much. E's mass was 83,
How'd you know that?
because there were, so the first row was 8 and the second row was 7. There were 1, 2, 3, 4, 5, 6 rows of 8, so 8 times 6, which equals 48, and then 7 times 1, 2, 3, 4, 5, which is 35 and then add them.
So you counted the number of dots in there. Exactly. Counting the number of dots in each square will tell you the mass of the object. Once you find out which square has the most dots, that square has the most mass. Okay? Now, look at number 3. Which object has the largest volume? Brooklyn?
C
Why C?
is because it's more compact and it's closer together.
That's density. Density is they're more compact and closer together. Volume is strictly the size, how much space the box takes up. Brooklyn, try again. Which one has the largest volume? Why?
It's because it's
It's the biggest square, the biggest box. Do you see how you have to be very careful? Okay, hold on. Don't work on it right now. Go to the next page. Cross off number 10 and cross off number 12. We're not going to complete those, but you are going to do the rest of them. Then lastly, go to the very back page. Okay? Read the top part up here. These 2 lines having to do with mass. Luke?
Wait, so I read the definition of mass.
And then use a balance and weights. Yep.
mass, the amount of matter inside an object. Use a balance and the weights to determine the mass. Mass does not change based on the weight.
Read the information for volume. Connor?
Volume, the amount of space a piece of matter takes up. Rectangular prism volume is length times width times height. an irregular solid using a beaker, measure the amount of water displacement.
And read the info for density. Sadiksha?
How tightly packed the molecules are to another mass per unit. Density mass divided.
Very good. Okay? Now, real quickly, down here. I want you to know this whole first row that I highlighted goes together. You go across. Here's the object. Here's the mass of the object. You need to find its volume. To do that, hint, hint, you're going to use that formula. Then, by using the mass and volume, find the object's density. Okay? Follow the same process we did in the notes. Same thing down here. A new object. Here's its mass. You got to figure out what it is total. Find its volume. Find its density. Okay? Any questions on how to do this? Ian?
So what would be right for on the top row for the type of measurement, like it's grams and
Mass is grams. Volume is in milliliters. So these are all going to be in grams. Volume will all be in milliliters. And then your density is gram/milliliter cubed. Okay? I would write all those down. So you have them. Okay? All right, you can begin working. No, it does not need to be in cursive. Technically it should be, but I'm not going to. I'm more worried about you getting it right.